Hello class, today we're on lesson 4.8, L'Hopital's rule. So as you saw from the videos, we kind of have an idea, well we do have an idea of what L'Hopital's rule is, so let's just kind of go over it just briefly. So we use L'Hopital's rule when we are evaluating a limit that comes out in an indeterminate form. Indeterminate form would be any one of these forms where we have 0 over 0, infinity over infinity, negative infinity over infinity, infinity over negative infinity, or where both infinities are negative. Now, by taking the derivative of the top and bottom separately is the key word here, we can come up with the limit, right? So, let's go through these and see what we get here. I know I gave you a few examples, or a few video examples, but these are just kind of some examples that didn't really come up in the videos that I sent. So I kind of want to go over some other cases that might happen. So, let's start with the first example. The limit as x approaches infinity of x cubed minus x squared over e to the x plus 1. Well, let's first see what happens when we just evaluate this thing. What happens when we plug in infinity in for x, and I know we can't really plug in infinity, but what happens as x becomes extremely large? So we can see this top part. Well, let me just rewrite this. The limit as x approaches infinity of x cubed minus x squared for e to the x plus 1 is equal to, well, let's see, the top part is going to get very large, so that's going to approach infinity, and the bottom part is going to get very large, that's going to approach infinity. So here we have a limit that's an indeterminate form. Well, let's apply L'Hopital's rule and see what we get here. No, this is cubed. See what we get here. So, let's take the derivative of the top and bottom separately. So the limit as x approaches infinity of this is going to be 3x squared minus 2x over the derivative of e to the x is e to the x. Derivative of 1 is just 0, so that goes away. And let's see. If we evaluate this limit, well, let's see here. Well, if we plug in infinity, it's again going to be infinity over infinity. So let's take another derivative and see if we can come up with this. So the limit as x approaches infinity of, now it's going to be 6x minus 2 over e to the x. Again, if we were to evaluate this, we would get infinity over infinity. This is a linear function that as x approaches infinity, will also approach infinity. So again, we have infinity over infinity. Let's try it once more, and maybe you can see where we're going here. So we have the limit as x approaches infinity of, let's see, this is going to be 6 over e to the x. Well, let's see here. This is very nice. This is just going to be 6, and this is going to be infinity if we plug in infinity. Well, this just goes to, if this gets very, very large, infinitely large, then this will just trend to 0. So the limit of this as x approaches infinity is 0. All right, let's take a look at this next one. So now we have the limit as x approaches infinity of ln of x over x minus 1. So let's first try to evaluate this, and we kind of all know where this is going to go, right? Ln of x over x minus 1. Well, this is, if we plug in infinity for ln of x, this is going to trend towards infinity. And here, x minus 1, well, that's going to be infinity minus 1, which is just infinity. So this is infinity over infinity. So let's take the derivative, use L'Hopital's rule, see what we get. So we have limit as x approaches infinity of, let's see, the derivative of ln of x is 1 over x divided by x minus 1, and x minus 1, the derivative of that is just 1, right? The derivative of x is 1, negative 1 goes away, which this equals the limit as x approaches infinity of just 1 over x. And what happens when we plug in infinity here? Well, it's going to be 1 over infinity, which is, again, like this example, our first example here is going to be 0. So the derivative of ln of x over x minus 1, well, the limit as x goes to infinity of this is 0. Awesome. Now let's do this last example. So this is the limit as x goes to 0 of sine 3x over 3x. So let's go ahead and see what happens here. The limit as x approaches 0 of sine 3x over 3x. Let's see here. Sine well, if we plug in 0, it's going to be 0 times 3, which is 0. Sine of 0 is 0 over 3x. Plug in 0, you get 0. So again, we have this indeterminate form. So let's apply L'Hopital's rule to take the derivative of the top and take the derivative of the bottom separately. So the limit as x approaches infinity. Let's see, this is going to be, we're going to have to use the chain rule here. So the derivative of the outside is going to be cosine of 3x times the derivative of the inside, which the inside is 3x. So that's just going to be 3. So our derivative is going to be 3 cosine 3x over 3. And let's see here. We plug in 0 for cosine. Well, sorry, we plug in 0 for the x here. And 0 times 3 is going to be 1. Or sorry, this is going to be 0. Cosine of 0 is 1 times 3 is going to be 3 over, and this is just going to be 3, so that is just going to be 1. So that's all I have for y'all today. Hopefully you enjoyed these videos. So get started on the worksheet. Let me know if you have any questions. Bye.